Hey guys, we are going to study molecular Lewis dot structures today. I'll give you some guidelines, and I think of them as really being three different kinds of structures. That is, molecules that contain two atoms, molecules that contain more than two atoms, and molecules that contain carbon are even more special. We have a bookwork associated with this lesson. It's several questions, so we'll try to make the mini lecture in class extremely short. And there's also a quiz associated with this lesson. So make sure you've been studying for that. It's going to cover ionic bonding, covalent bonding, properties of them, and stuff like that. All right, so the aim is how do you draw Lewis dot structures for molecules? And copy down this do now. We are going to do it in class tomorrow, so get the questions copied down, and you don't need to bother answering them, just get them ready on a separate piece of paper under classwork. All right, so here are my guidelines for drawing molecular Lewis dot structures. Firstly, the question reads, covalently bonded atoms never give away electrons. Why? So think about that for a second and then come back. So my answer is that nonmetal atoms have high electronegativity and therefore they won't give up electrons. And covalent is a word that goes with nonmetals. All right, let's take a look at this next piece. Atoms in covalent bonds share the same number of electrons that they need in order to fill their valence shells. So just to help you unpack that, covalently bonded atoms share electrons, and the number of electrons that they share is actually determined by the number that they need. So they share the same number of electrons that they need. Consider the molecule CH4, which should really be written like this, with a little 4. How many electrons would each hydrogen atom share? So you have to use the logic I just said. It'll share the same number of electrons that it needs. So hydrogen atoms will share the number of electrons that they need. And for hydrogen, they need 1 electron, so that means they'll each share 1. But carbon, which is my next question, carbon needs 4 electrons, which means that it will have to share 4 electrons. So I know that logic is kind of backwards, but it is a good way to draw these dot structures. Just think about how many electrons that atom needs, and that'll also be the number of electrons that it shares. Here's my next thing is that if the molecule contains only 1 atom of one element and more than 1 atom of other elements, like this guy, so it has only 1 atom of carbon and 4 atoms of hydrogen, then the central atom in your drawing is going to be the element that has only 1 atom. So when you are going to draw a molecule for CH4, what you are supposed to know from that little bit is that since there's only 1 carbon, it's going to be in the middle, and these hydrogens will surround it. And if you have the case of a tie, where there's more than 1 element that only has 1 atom, then you need to choose the element with the lowest electronegativity, and that will be the central atom. So I'm going to circle that because it's definitely a detail. It won't come up much, but you'll be happy you remembered it when it does come up. And then here's another note of just something to never do. Hydrogen can only form 1 bond. So never under any circumstance give hydrogen more than 1 bond. It cannot be done. So just, I'm going to put a star beside that as well. Hydrogen can only form 1 bond. And lastly, we might use dashed lines like this guy right here. And dashed line can replace dots that represent the electrons in a bond. And basically every dashed line represents 2 electrons. So this is going to be based on the molecule H2 right here. It should really look more like this. And my question is, how many electrons does each atom need? So for hydrogen, hydrogen needs to gain 1 electron, and that's also the answer for how many electrons each atom will share. So I just suggest drawing the 2 hydrogen atoms next to one another, and they each are going to put their bonding electrons between them, and this is what is going to result in a covalent bond. And then I also advise you to symmetrically distribute any remaining valence electrons. Now for hydrogen there aren't any more, so this is the only one. And then lastly, in this box below the dot structure, let's redraw it, but remember from just a few seconds ago, you can replace 2 electrons with 1 dashed line. So that is a complete drawing. I'm going to work through HBr with you as well. Just draw the 2 atoms next to each other. And then think about how many electrons each atom needs, and that'll tell you how many each atom shares. So hydrogen needs to gain 1 electron, so it's going to share 1 electron. And bromine also needs to gain 1 electron. It's in group 17, so it has 7 valence electrons already. So it needs 1, so it's going to share 1. And then remember to symmetrically distribute any remaining valence electrons around the atom that contains them. So for bromine, it has 6 more electrons other than the 7th one that I just put in earlier. So I'm just going to put 2 electrons per side on the remaining 3 sides. And when I do my final draft, I'm going to replace those 2 in the middle with 1 dash. But these electrons that are going around the outside right here, the non-bonding electrons, they can't be replaced with dashes. Alright, now I'll do chlorine for you as well, and then I'll ask you to take a guess at nitrogen and oxygen. So for chlorine, again, this is structures for molecules containing 2 atoms, so you just draw them next to each other. Each is in group 17, so each has 7 valence electrons, and that means each wants 1 valence electron, so each is going to share 1. So these are the 2 that each is sharing. And then remember each of them had 7, so you need to put in the other 6 for both atoms. I do want you to pause the video now and then come back for the final draft. So it's very similar. I did replace the 2 electrons in the center with 1 dash though. Alright, so I just want you to take a look at nitrogen, N2. And I want you to at least think of, before you draw it, at least think of how many electrons should be between the 2 nitrogen atoms. Pause the video and then come back. So since each nitrogen atom is in group 15, then that means they have 5 valence electrons and they each need to gain 3. That means each of them will share 3. So I'm drawing those in now. I'm lining them up like this because those are going to become bonds in between them, in between the pairs of the opposing nitrogen atoms. And then remember, each of them had 5 valence electrons, and I've only shown 3 for each of these atoms, so you need to show 2 more. And I just put them on the opposite side. And in my final draft, I'm going to have 3 lines instead of 6 dots. But the lines can't replace these dots. These are the non-bonding electrons. Alright, base your answer on what you just learned with nitrogen, and try to do oxygen by yourself. I will tell you that it's going to have a multiple covalent bond, just like nitrogen. It's going to have more than 1 bond in between the 2 atoms. But think about how many bonds you think it should have, and why. Okay, so here are my 2 oxygen atoms. They're in group 16, which means they have 6 valence electrons, and each one needs to gain 2 electrons, and that's also the number of electrons that each will share. So if each of them shares 2 electrons, then what you have is a double bond in between those 2 atoms. Now they were in group 16, they had 6 valence electrons. Right now, I've only shown 2 electrons per atom, so there are 4 electrons I haven't shown yet. Try to keep it symmetrical so you can sort of put them in the diagonals there to keep the electrons as far away from each other as you can. And my final draft should look a bit better. I did replace the 4 electrons in the center with 2 bonds. This slide is for Lewis dot structures for molecules that contain more than 2 atoms, such as this guy, H2S, which should be drawn like this, H2S. Remember to draw the Lewis dot structure of the central atom first. That's going to make these special. So the central atom is going to be sulfur because there's only one sulfur. And here's the dot structure. It's in group 16, so it has 6 valence electrons. The first two go together, and then you alternate. So that's my third, fourth, fifth, and sixth. The central atom has 6 electrons, so it's going to share 2. And the other atoms are hydrogens. They need 1 electron, so they'll each share 1. And I don't know if you already know what's going to happen here, but this is what's going to happen. This hydrogen atom will share 1, it fits nicely into that slot. And then this hydrogen atom will share 1, so it'll fit nicely into that slot. And when I redraw it, I'm putting in a line for each of the 2 electrons in the bond. So these 2 electrons are in a bond, and that's what this line is. Same thing for that hydrogen, but don't forget the 4 electrons that are not involved in bonding. All right, good. One thing that's interesting here is that this is not a symmetrical molecule. It's lopsided. It has this hydrogen end and it has a sulfur end. We call this shape bent. I know it's not very creative, but this is a bent structure because, yes, it's bent. I'm going to do water for you, and then I'm going to ask you to try ammonia on your own. So here's water's central atom. It's oxygen. So draw the dot structure for oxygen, 1, 2 to go together. Here's my third, fourth, fifth, and sixth electron. And then for the hydrogens, they're each going to share 1. There's a hydrogen, and here is a hydrogen. And so my final draft is another bent structure. And those are my 4 non-bonding electrons. All right, so think about ammonia now. What's going to be the central atom? Draw its dot structure, and then put the hydrogens in the locations that you think fit. There are 3 hydrogens. And pause the video while you do that, and then come back. All right, so here is my nitrogen central atom. It has 5 valence electrons. The first 2 go together. There's my third, fourth, and fifth. And my hydrogens are going to go on the 3 spots where there's an empty space for electrons. So there's 1, and there's 1. And my final draft should look a bit neater. And there it is. All right, pause the video. I want you to work on PCl3 and H2SE. And when you come back, you'll see complete solutions for both. All right, I'm going to zoom in here and talk about each of these. So PCl3, I started with phosphorus. That's in red here. And it's in group 15, so I gave it 5 valence electrons, 1, 2, 3, 4, 5. And then the chlorines each were going to share 1 electron, so that's what it went in these slots. And I remembered to put the non-bonding electrons around each chlorine. It was annoying, but that is the correct way to draw the structure. And when I cleaned it up, it came out looking like this, just phosphorus in the middle, 3 chlorines, 3 dashes. These 3 dashes replace these 6 electrons. And then you still have these 2 that were right here on the phosphorus, and then of course your non-bondings go around the chlorines. Dihydrogen selenide. Here's my selenium atom in the middle, and it's in group 16, 6 valence electrons, 1, 2, 3, 4, 5, 6. And then I have my hydrogens that just go there, almost like water, exactly like water actually. And here's my cleaned up version. These 2 electrons are here, and these 2 electrons are here. These 2 electrons are a bond, and these 2 electrons are a bond. My last slide of drawings is going to focus on molecules that contain carbon. And like this guy right here, who should be written more like this with like a small 4, it's called a subscript. The thing about carbon is that it's usually the central atom, and its electrons can be arranged symmetrically. And they're much more flexible. You don't have to draw them with rigid dot structures, meaning you do not have to draw carbon like this, where it's 1, 2, 3, 4. It's not, carbon doesn't arrange its electrons like that. It's part of carbon's electron shell properties. So you just need to know that this is possible for carbon. And additionally, a carbon in the middle, 2 electrons on the left, 2 electrons on the right, this is also possible. So just be aware of that. It's just going to depend on how many things it's bonding to. If a carbon's bonding to 4 things, use that. If it's bonding to only 2 things, use this. All right, so carbon will be the central atom, and the number of electrons that the central atom will share in this case is 4. And the total number of electrons that will be shared by other atoms would also have to be 4. So let's draw CH4. There's my central atom. It's going to have 4 hydrogens, so I'm going to choose to put my electrons for carbon like this. And I'll do them in red. 1, 2, 3, 4. And then my hydrogens will be in blue. Obviously, I think they're going to go on the 4 sides. And each hydrogen will share 1 electron in blue there. And when I clean it up, all 4 of those electron pairs are going to become lines instead of dots. So you just get this nice symmetrical C in the middle, 4 H's around it. All right, let's do carbon tetrachloride. It's bonding to 4 chlorines, so I'm going to do 1, 2, 3, 4 like the last time. And the chlorines will, I think, obviously go on the 4 sides. But chlorine is in group 17 and has 7 valence electrons. It's going to share 1 as a result. So I'm putting those in now. And since it has 7, I need to show 6 more for each atom. All right, there it is. I'm going to clean it up. So there she is. Here we are with a really interesting example. We have a carbon and a chlorine, 3 hydrogens. It's hard for you to tell which atom goes in the center because you have 2 atoms here and here, both of which there's only 1 of. But just know that carbon will be the central atom. It also has the lower electronegativity. So I'm going to put carbon here in the center, and it's going to be bonding to 3 hydrogens and 1 chlorine. That's 4 things. So I'm going to distribute the electrons like this. I'm going to put hydrogens on 3 sides with 1 electron involved in the bond with the red one. And then here's my chlorine. It's going to put 1 electron into the bond as well because it has 7 at the moment. And then it needs to have 6 more. So when I clean that up, it's going to look like this. All right. I want you to try CBr4 by yourself. You can try CO2 if you want, but I think CBr4 is more approachable for you guys. Pause the video and then come back and you'll see a solution. Okay, so I know this one looks like a mess, but I'll zoom in for you. I have the carbon in the middle, 4 electrons going 4 different directions, and my bromines all will have 7 red electrons around them, but they're each contributing 1 into the bond, so you do have 4 bonds, and I showed them down here as dashes with the 6 other electrons from bromine surrounding, so those are there. I'm going to zoom back out though, because you do need to do carbon dioxide. It is not the easiest one in the world to do, but here's what I would point out. The 1 carbon is bonding to only 2 oxygens, so it's going to be using this electron configuration in blue, where you have 2 electrons on the left and 2 on the right. That may not be immediately obvious about why right now, but it'll become clear. So carbon in the middle, 2 electrons on the left, 2 on the right. And the reason why it's doing that, I'll switch to red for oxygen. Here's 1 oxygen and here's the other. is because, so oxygen's in group 16, it has 6 valence electrons, so it needs to gain 2 electrons, and that also means it's going to share 2 electrons. So I'll put those here. Each oxygen is sharing 2 electrons because it needs to gain 2. And you might see that those 4 electrons in between each oxygen and the carbon are going to become a double bond between each oxygen and the carbon in the middle. But remember what I said, oxygen had 6 electrons, so you have to show all 6. Let's finish that out in red. And then I'll clean it up down here. There's my carbon. I just put in a double bond on the left and on the right. The double bond right here on the left are these 4 electrons, and then there's one, and here's one. Okay, so got my 2 oxygens, and don't forget your 4 non-bonding electrons. Alright, so that's it for that slide. So here's your pair up. Copy this down and have this ready underneath the do now, and have it ready for classwork tomorrow, so it'll be on that separate classwork paper. And I just corrected some of the formatting errors that were produced by the app, so those are there for you. And here's your summary. I think obviously this guy is really supposed to be H2O, and this one should be CH3Cl. So thank you for listening and taking notes, and I'll see you tomorrow.